We have achieved great things. We have made giant leaps. We've gone far beyond what we thought was possible. But we have only just begun. Our future in space is unlimited, and it will benefit all humanity. But it will take hard work, new technologies, advanced financing models, and enabling public policy. The Beyond Earth Institute is creating a policy and legal framework to enable the creation of economically vibrant communities beyond Earth. We will engage all stakeholders on critical policy issues: property rights in space, norms of behavior, conflict resolution protocols, filling the technology gaps, exploring new financing mechanisms, and making space settlement an agreed goal of the U.S. and its allies. Beyond Earth is committed to the true purpose of why we go to space. Join us on this journey.
Welcome to this Beyond Earth webinar. We have an exciting program for you today entitled "You're Going to Need Juice for That: Establishing Infrastructure in Space." My name is Steve Wolf. For those of you who don't know me, I'm the president and co-founder of the Beyond Earth Institute. This is yet another one of our fantastic webinar series. Before we get into the program, before I introduce it, I just really wanted to share with you some interesting things that have been going on in the organization recently and some announcements. And it's very appropriate that we're talking about lunar and space infrastructure today. And I'm actually using my lunar backdrop because lunar is very much on the mind. Tyler, who's moderating this program, was with me in Washington on Tuesday and Wednesday when we had a series of meetings on Capitol Hill and at NASA. We wanted to meet with these folks and we wanted to update them generally what Beyond Earth was doing. We were handing out copies of our report of recommendations that came out, 120 pages of including 7 reports that we generated last year. We are well underway now of the 2025 cohort of working groups that are developing, having discussions on a range of topics from commercial space stations, human survivability in space, and of course, cislunar economy and cislunar dwelling. Well, one of the things that we were talking about in Washington on the Hill and at NASA was an initiative that, in my mind, is a culmination of much of the work that we've been doing in our working groups, particularly around the cislunar economy. How do we finance it? What it's going to look like, and so forth. We've been we're all very excited about the developments that many of you might be tracking, that NASA really is investing somewhat into the infrastructure technology for operating on the moon and around the moon. Obviously, that's going to be in support of the Artemis landing that's coming up, and we're very excited about that, at least in a couple of years. And then, of course, but our biggest question has been, almost from the beginning of starting Beyond Earth, is what happens after Artemis, right? So we're all very excited about the Artemis missions, but frankly, it's very unclear where we go after we have made some more footprints on the moon, which is great. It'll be great. But we want sustainability. We want to have permanent human presence in space. And the White House, frankly, that's a mission, or that's a requirement that's been stated by the White House. But clearly, we're not seeing that reflected in actual mission that have been articulated by NASA or anyone else in the U.S. government. Of course, it has been articulated by China, right? So the Chinese very much are committed to having a lunar research station. And this sort of gets to where we're at. We've been floating. We're in the beginning stages, and this is where we're going to need input from a lot of folks and a lot of folks probably on this call. But we're starting an initiative where we're saying we want to make the case for a US-led lunar research and development facility. Okay. And this is what we're proposing, that this be a mission priority for the United States. Quote, the United States, in partnership with its allies and industries, shall commit to creating a permanent international public-private lunar facility that will support 50 or more personnel, 50 or more personnel to conduct basic research and technology development in pursuit of peaceful commercial utilization of lunar resources. So that's a big ask. Um, that's a big ask. And so that's just a bit of a teaser for you. And one last teaser in this regard is I want to share with you a video that we've been sharing on the Hill, and I think it's very appropriate to the conversation today. And you'll see this video. It is a design or a CAD animation that was developed by Daniel Innocente, who with DIA architecture, who had worked with Blue Origin and had worked with major architecture houses, Skidmore, Owens, and Mather, and we worked with him directly last year, and he produced this video for the Beyond Earth Institute, which he actually first showed at the Beyond Earth Symposium last November. For those of you who were there, remember Daniel's excellent presentation. But let me share that with you right now.
Imagine a future where humanity establishes a sustainable presence on the moon. Along the edge of a crater rich in water ice, we see the beginnings of a new era of exploration, guided by principles of sustainability and efficient resource use. This vision includes dedicated landing zones for cargo and human missions, safely distanced from the main base to prevent dust damage. Autonomous rovers transport supplies from these zones, reducing risk to humans. A key strategy involves in situ resource utilization. By extracting water ice, we generate drinking water, breathable oxygen, and even rocket fuel, reducing reliance on Earth resupplies and ensuring sustainable habitation. The base uses a hybrid energy system, combining solar arrays with compact fission reactors. Solar panels are elevated to maximize efficiency and avoid lunar dust, while nuclear reactors provide continuous power during the 2-week lunar night. Thermal batteries store surplus energy, ensuring resilience. Inside the habitats, closed-loop systems recycle air and water, maintaining a self-sustaining environment. Reconfigurable interiors support living, research, and medical needs, while AI-driven health monitoring ensures crew well-being. Autonomous controls and augmented reality interfaces allow the crew to efficiently manage life support and resource extraction, overcoming communication delays with Earth. These technologies enable the habitats to operate independently. Designed for scalability, the habitats use modular docking for seamless integration of new labs and living spaces. This adaptability supports a growing mission scope, turning the moon into a stepping stone for a deeper exploration. This sustainable lunar base is more than an outpost. It's a blueprint for expanding beyond Earth. By leveraging local resources and innovative technology, we prepare for a future where the moon serves as a gateway to Mars and beyond. Imagine a future where humanity establishes a sustainable presence.
Okay, cool stuff, I hope. So just stay tuned on that. If you noticed, one thing I want to bring attention to, you saw that there was a series of nodes, if you will, that were sort of hexagonal in shape. So just for reference, one of those nodes that has multiple habitats in it would house about 50 people. So that's kind of where we want to start. In the long term, of course, we'd want to expand that. We'd want that to be scalable over time. So cool stuff. Stay tuned for more of that. And anyone's interested in being involved in that project, certainly let me know. Um, We have a date set for the next Beyond Earth Symposium. It is February 24th and 25th. So we are moving from the November date to a February date. Just be aware of that. It is we are titling that From Habitat to Space Town. Will this be the Wild West or a rules-based order? So we're looking forward to being to really developing that. And please do note that on your calendar. Our next webinar is coming right up. It looks like I did not. I think it's towards the end of the month. I apologize, I didn't jot it down, but be on the look for that. Out for that. It's going to be titled Eat, Play, Love. It's sort of a takeoff on Eat, Pray, Love, and we'll have astronaut Scott Parazinski, Dr. Shauna Padya, and Linda Reinstein. So if you know those folks, it's going to be a particularly good event. So now let me move on to today's program. And before I introduce the moderator, I do want to mention that we have a guest panelist today. That's Charles Miller, who has he'll be introduced right now. He's the president of NextGen, but he has a long history. He was most recently served as the transition team lead for NASA for the incoming Trump administration. So he's been a good friend of mine for over 40 years. We met in Washington way back in the day and shared a deep passion for space and the potential for human expansion into space. So I'm really glad that he was able to join us and certainly has a deep knowledge on many topics, and including the one we're going to discuss today. So thanks, Charles, for joining us. Now I want to introduce Tyler Bender, who is a research analyst for the Beyond Earth Institute. He's been part of our team for over 3 years now. He is integral to what we're doing, and he's certainly an important part as he works at FAA in their policy department and in the Office of Commercial Space Flight Operations. So with that, I'd like to turn this over to Tyler for your able hands to lead the conversation.
All right, thanks a lot, Steve. Looking forward to our conversation today. Welcome everyone to our Space Juice webinar. As everybody knows, nothing in space is possible without power and propulsion. And if we're going to enable communities beyond Earth one day, it's going to make a lot more sense to source fuel from in space as opposed to on Earth. And our 4 panelists today are people who know a lot about how we're going to get to that future. First, we have Joe Pawelski. Joe is co-founder and chief technology officer of Syslunar Industries. Syslunar builds power processing units that can be used for a variety of space missions. And they also recently received new funding to expand production. Congratulations on that, Joe. Syslunar is also developing a module that will melt down satellite components in space into fuel rods that can be used for in-space propellant. Welcome, Joe.
Thank you.
Next is the first guy I met in the space industry a few years ago, Dallas Bienhoff from Offworld Inc. Dallas is the space systems architect for Offworld, and he also leads their Syslunar transportation development efforts. Prior to joining Offworld, among many, many other things, Dallas founded the Syslunar Space Development Company, where he defined and promoted a reusable space-based Syslunar transportation architecture. Welcome, Dallas. Next, we have Ross Centers. Ross is the co-founder and chief executive officer of Ethos Space. Ross has a background in lunar geology and is using that experience to lead Ethos in developing technology that will be used to melt down lunar regolith into solid rock that will then be used to create landing pads on the moon. And then that can also be used to process oxygen that will be used for propellant. And last but not least, we have Charles Miller, our special surprise guest. Charles is the co-founder of Link Global, president of NextGen Space, where he has provided strategic support to NASA and DARPA in projects related to lunar architecture and in-space refueling. He also led the NASA transition team for both the Trump-Pence and Trump-Vance administrations, and most importantly, he's an advisor to the Beyond Earth Institute. Thank you, Charles, and welcome.
Glad to be here.
So I'm going to turn things over to our panelists. They're just going to give about a 5-minute presentation on in-space refueling from their perspective, and then we'll go to about 30 minutes for the moderated discussion. Then we'll leave plenty of time at the end for questions from the audience. So if a question comes up, feel free to just add it to the chat, and we'll get to it towards the end. And Joe, go ahead and kick things off with your presentation.
Great. All right, can everybody see that okay? It's like, there we go.
Got it.
Okay, cool. All right, well, so Cislunar Industries, like a lot of startups, we've started out focusing on metal processing for space. And we quickly realized that in order to do everything, to capture these materials, to take derelict debris and turn that into propellant, to take things from the surface of the moon and get it there and use that as well, we were going to need logistics. And the crux of logistics in space, of course, is how do you refuel? It's that whole rocket equation. You know, you run out of gas and then you're screwed. So you need a way to refuel, to replenish, to really start to do the dynamic space type of activities that we'd like to do that are required to have a cislunar economy. So again, we started out with a NASA Phase 1 to build a capability to recycle things on orbit. Namely, there's 13 most derelict upper stages that we were looking at. And we realized that, there's a number of ways, pretty much anything you can ionize, you can use as propellant. Anything that has mass, for that matter. I mean, it's Newton's law. If you can accelerate it fast enough, you have a rocket engine. So we realized that the aluminum on an upper stage was a pretty interesting thing, and that is an in situ resource. It's already on orbit, and it's a tragedy of the commons. Nobody wants to spend the gas to get there, because gas is the most expensive thing, or one of the more expensive logistics problems on orbit. So we were like, well, what if we could turn that mass into delta V? And this is where it came up, this concept, debris to delta V. So interesting enough, in a direct-to-phase 2 called Metal Propellant Ecosystem, that's what this slide comes from, we analyzed what would it take to go harvest these upper stages, take 1 to 10% of the metal off of those and use as propellant, and then store the rest in a graveyard somewhere, in an orbital salvage yard. We also looked at what would it take to derive metal from the moon, because we figured Starship is probably going to need, and other things are going to need a lot of oxygen. The byproduct of oxygen extraction is metal. So, obviously you can build things with metal, but you could also use it as propellant. Wouldn't that be an interesting source? Looked at all these things. Ultimately, what we realized is the real interesting logistics to on-orbit servicing, refueling. They're all sort of similar. And that's, we looked at the ConOps and realized that, hey, if you're in the same neighborhood, let's say, and this is very similar to how satellites are. I mean, space is big, but the reality is that people tend to, when you drive around out in the countryside, there's a few sparse houses, but then there tends to be these towns and cities where everybody is collected. This is very similar in space. There's places where geosatellites all tend to cluster. There's spaces where LEO satellites tend to cluster. So they're all in similar neighborhoods. So we started looking at these ConOps. We were like, okay, well, this is kind of interesting. There's an opportunity to replenish, not just do ISAM, but and refueling, but to replenish everything in a propulsion system, and all kinds of different propellants. It doesn't just need to be metal. Metal is very interesting. But at least the current technologies for metal aren't necessarily high thrust. So, chemical propellants, all kinds of other propellants follow along with this whole neighborhoods idea that you can actually do this with not expending a lot of gas to actually do the servicing. So anyway, that led us into a bigger ecosystem here, where we started looking at this and saying, hey, okay, well, what are propellants that we have to source from Earth? What are propellants that could be in situ? And again, we're Cislunar Industries. When we think of the name Cislunar, we're not thinking just geo and beyond, which I think is typically what a lot of people think. For us, Cislunar is really the Earth-Moon system. And it's that whole ecosystem that we think is going to need to form between the Earth and the moon and that ecosystem. So some propellants, your xenons, things like this, they're going to need to be sourced from Earth. Xenon's a great propellant, though. So there's a lot of applications where, that's going to be utilized. Same thing with krypton. But there's other propellants, aluminum, like I mentioned, and water, that can be sourced from the moon. And this is phenomenal because, as you can see here on this chart, aluminum vapor hull thread, these are still research level, but there's companies, Starlight, that's using magnesium. There's some magnesium on the moon. You can get pretty high performance out of totally sourced in situ materials. Also, water. Water provides pretty interesting capabilities for thrust and for specific impulse. So anyway, what these charts are, if anybody's not following on propulsion, what these charts are really showing is thrust as a versus time. So with a high thrust system like a arc jet, hydrazine, things like that, you're gonna move a lot faster. So you can get out of the way. You can make evasive maneuvers for a micrometeorized, things like that. But you're gonna run out of your ultimate delta V is going to be limited. If you use something like hull thrusters, your capability for delta V is very large, but your time to get there is that's your sacrifice there. So anyway, we realized that, hey, there's a pretty interesting opportunity here. Some of these things can be sourced from Earth, but a lot of these things, maybe once you get your satellites on orbit, could be sourced from the moon. And depending on where you are, for those of you that understand delta V, it's a lot easier to get something from the surface of the moon to LEO even than it is to launch something from the ground to LEO. So there's tremendous opportunity there. And again, just we whittled down and realized that logistics, delta V, propulsion, that's really key. That leads us to this ecosystem that I know Dallas is going to elaborate more on, and everyone else on this, but wanted to really get some Imagineering out there for what this might look like. So our current work, we've come a long way since Modular Space Founders. We are still working on these. We have some flights planned for that. But a lot of our focus has been on how do we provide the logistics layers for that. And this is one of these concepts here for a line replaceable ecosystem. And the idea is, you might want to use a high thrust propellant. You might want to use a low thrust, high specific impulse. You might want to use a metal thruster. So the idea that you can have a modular MOSA architecture for satellites, and starting with that propulsion level, so you can launch something that's got a propulsion system that uses xenon or something from Earth. And then once you get into a geo orbit or towards a cislunar or a lunar orbit, you might swap it for something that burns metal or water. A microwave water thruster could be a really good opportunity there that can be fully replenished, not requiring the Earth. So anyway, I could keep going on that. I want to keep to my 5 minutes, but that's really what we're looking forward to is the day when our whole ethos is we want to create abundant resources off world so that the idea of scarcity is never something that humanity has to think of. So with that, I think I'll stop here and let everyone else get a chance to chat.
Thanks a lot, Joe. Great way to kick things off. Dallas, now we'll turn to you to go more into the cislunar infrastructure for refueling.
Thanks, Tyler. Joe, love the modularity, love the approach, and different capabilities for different uses. That's great. That's a great idea. I'm going to talk a little bit about propellant depots and that infrastructure. So Off-World, first of all, Off-World is a robotic mining company. We are building robotic mining tools, autonomous mining robots for Earth and the solar system. And our team at the moment is in the early stages of our preliminary design phase for a lunar prospecting and ISRU technology demonstrating vehicle that we hope to launch in the next 3 to 5 years. It will collect science data. It will look for icy regolith. It will extract water and produce oxygen and hydrogen. And we have 3 different processors for oxygen from regolith on board at the moment. So that's the source on the moon that we are hoping to provide propellant on the moon and then also export that as economic conditions allow. But let's talk about propellant depots, because they are needed for, in my view, for an efficient cislunar and interplanetary transportation. They also provide other functions such as cross-docking, docking ports for OTVs, cargo storage, think a bus depot and multimodal transport facilities. They're a transfer point for moving goods between systems designed for different operating environments. The picture shown here is from an article that was just recently published online, the July 2nd. And so this is a notional way station, if you will, in Earth orbit or above another planet with a blue atmosphere, where folks come in, goods come in and be transferred, and stages are refueled. But let's look at a LEO refueling station. This is a concept I defined under my cislunar space development company days, but is now a part of the off-world IP. This is a water to LOX hydrogen propellant depot. It has 200 tons capacity for LOX hydrogen and also 200 tons for water. That is twice the propellant needed to go from Earth to LEO to deliver a 25-ton cargo and then return without refueling. And it's 500 kilowatts of power. It operates continuously in low Earth orbit. And it is a place to move goods from a launch system to a cislunar system. And I believe you'll see, if I were operating SpaceX Starship, they would have a similar architecture with a LOX methane depot as and a Starship to get to Earth orbit, a Starship to get to the moon vicinity, and then a Starship to land on the moon. And that would be followed by a lunar orbit refueling station. This particular one is in around Earth Moon L1. I believe a better operating location than NRHO, but there could be both. This also has the same capacity and the same power requirements, and it is to support 25-ton delivery to the moon and return without refueling, because it would be there before there is water production on the moon. It would also serve a round trip for crew and personnel going back and forth to the moon, and a transfer point from the cislunar vehicles to the lunar lander vehicles or moon shuttles. And it would receive water from Earth or from the moon if it's less expensive, wherever the least cost would be. It would buy water from those sources and convert it to LOX hydrogen for point of use. There's also room, as you see, some smaller tanks on the right side of the truss, smaller tanks for methane, in case there's methane operators at the same location. Not quite big enough for the Starship, but there are other people using methane in the CLIPS community, Commercial Lunar Payload Services. And then notionally, this is a mature, potentially mature cislunar architecture with depots, multiple depots in LEO at 28.5 and at 51.6, i.e. the space station inclination, the space station orbit. There could also be one at equatorial LEO to get us lower delta V's out to the GEO and onto the moon. There would be multiple depots in GEO to service the whole GEO environment, to receive propellant from the moon, to provide return propellant back to low Earth orbit, so you don't have to carry that propellant out and use propellant to move that propellant out to come back home. There could be at least 2 depots in the lunar vicinity, one at Earth Moon L1, my favorite location, or also in NRHO to support the Blue Origin landers for HLS for the NASA missions. And the size of the red line, the thickness of those red lines indicate the potential relative traffic along those trajectories. I developed this in collaboration with Pete Garrettson, a known Earth Moon logistics supporter. And then moving out from the mature cislunar architecture, depot in Mars orbit. This could be taken from the same design, moved out a little higher power because of or higher number of solar arrays because of the lower power density, but also could be water to LOX hydrogen or water and carbon dioxide to LOX methane. And this could be serviced by the Starship. It could be serviced by other transport requirements. And one would transfer goods from the interplanetary vehicles down to a Mars, over to a Mars ascent or descent ascent vehicle. And it could be supplied from Mars eventually, so that for the return trip back to Earth. And all of these stages that are using these, at least in my architecture, all of these stages, think of them as flatbed trucks, where they would push cargo, or they would push crew modules, or they would push water tanks or propellant tanks or nitrogen tanks between the depots. And having these depots there mean that the transfer vehicles only need to be sized for one-way delta V, which limits their size and eliminates the need to use propellant, to push propellant, to use propellant for the return leg. And with that, I will cede the floor to the next speaker. Tyler, over to you.
Thanks a lot, Dallas. So really moving from the Earth to the Moon to the Mars in the future, eventually we have all this built out. Ross, you want to go in more into ISRU on the Moon?
Absolutely. Get my slides up here. All right, y'all see those astronauts there? Great. So let's talk starting with Artemis. Like, here we are, we're on the surface of the moon, we're looking back at our fabulous lander system. Let's move on to permanence. Now what, right? And for permanence, we got to talk logistics, and we got to talk about, you're going to need juice for that. So when you're talking about refilling in space, especially with ISRU sources, you want to put the refilling point right where it's most cheap to get the product and where it's most expensive to deliver it from Earth. And that's right there at the lunar surface. It's not even an orbiting refilling depot. The cost advantage on this is incredible. You know, a Starship, you think about a 100-ton ship ready to go back just to EML1, 300 tons of that is liquid oxygen, right? And that liquid oxygen is right there in the regolith, right at your landing site. So what we do is we get that liquid oxygen, and we also solve another problem, which is how do you avoid throwing up dust and rocks and destroying your permanent infrastructure? So you get it like this. You can melt the regolith in situ right there, and it actually cools into a synthetic igneous rock, twice as strong as concrete. We've hot fire tested this. And while that regolith is molten, you can pull oxygen right out of it and get your fuel system there. Solves 80% of your prop refill mass. What you get there, boom, you get landing pads, as well as liquid oxygen. So now you can build up your permanent base with 50 people on it, and you can have all of the abundant power requirements you need nearby without getting fragged by rocks and hypersonic debris, right? And so all this takes a lot of power. Like there's no joke about it. This is not information. This is industry. You know, you're moving things up the enthalpic hill, but that's okay, because the opportunity here, and this is what I really want to get into, is immense. It is civilizationally transformative. What I want to spend most of my time here talking about is the strategic geography of the lunar poles, right? Like, why are we doing this? You know, why are we going beyond back to the moon, but building a base to stay? What you see here is a zoomed in region of the South Polar area. The blue and purple are things that are very highly ice favorable. These are permanently shadowed craters with not just water ice. This is not good, clean water that you drink from. This is ice that is also rich in nitrogen and carbon. So you can make a whole milieu of fuels. You can make hydrazine off this. You can make methane off this. You can have a whole chemical plant in there. The opportunity for that is astounding. If we're going to be having a permanent base on the moon, shuttling back and forth, That also means we're going to be living in a world which is, approximately close to Elon's ambition of building a city on Mars. And that's going to be 1,000 starships going back and forth to Mars, taking gas, right? So, SpaceX's goal is to put 1 million tons a year into low Earth orbit. And if most of that's going to Mars and most of that is prop, then you're thinking of about, 750,000 tons, 800,000 tons of prop just going up the gravity well from Earth. That's a market that you can supply by piping this stuff out from the moon. So it is really like the Persian Gulf. This maps in exactly historically to Winston Churchill converting the British fleet to oil and going up and opening the Persian Gulf to an energy source. And that set up the geopolitical structure of power, energy security, and blue water geopolitics on Earth. And this is it, right? So these bases that we're building, that we're going to build up for human expansion and permanence and to go beyond Artemis, they're going to be located in these orange areas where there's a high availability of sunlight, benign temperatures. This regolith can be used to make solar panels. It's 23% silicon, and there's 14% aluminum, so you can make everything you need for solar panels there. You can also drop nukes if you want to bring them from Earth. Nukes are heavy, but they're great. But we're going to need surface infrastructure to really build out the moon, to really build out a propellant export ability, because these areas where you want to build your bases that have benign temperatures are tens of kilometers away from these deep, dark craters that are inhospitable. So we view the proper architecture as first dropping a base that lets you have repeatable, safe landings with pads, then adding on-site oxygen refills and propellant refills, and then pushing out energy infrastructure, roads, cabling, piping, all made with lunar aluminum, lunar silicon, lunar rocks into these craters. These blue craters are about the size of Los Angeles basin or the Washington, D.C. metro area. They have hundreds of millions of tons of water ice in them and tens of millions of tons of co-products. So I think that's the new Persian Gulf. That's the new strategic energy infrastructure of the world. So there's something to talk about.
Thanks a lot, Ross. Fascinating stuff. And Charles, you want to close things out with the presentations?
All right. Well, great to be here. Thank you, Steve. Thank you, Tyler. I've been thinking about propellant depots for probably 35 plus years. To me, they go hand in hand with reusable launch vehicles. They're perfect partners, and the world we're seeing as reusability and launch vehicles is coming. Propellant depots is coming too. A little bit of background: I've led teams at NASA. Looking at propellant depots going back to 2009 through 2012. I've supported DARPA's RSGS program for propellant refueling in GEO. And I also led a study for NASA, the Evolvable Lunar Architecture, that had a propellant depot at its core on the moon. So all this is based on that. But I just want to first mention the idea of propellant depots is 102 years old. First written about in a book by Herman Oberth in 1923 called The Rocket into Planetary Space. So everything that all of us are talking about here is that you use propellant refueling to extend and make more capable. It's common sense. It's been known for over 100 years. And to me, this is inevitable. This is where the puck is going, right? The question is, when is it going to happen? How is it going to happen? Who's going to be part of making it happen? I have, since I was the leader of the Evolvable Lunar Architecture in 2015, funded by NASA, that informed the Trump tense deep space strategy that's in the budget, a COTS-like approach to the moon. This is at the core. We are going to mine the moon for its resources. One of the earliest resources is propellant. And so just let me share a little bit of, why I'm convinced of this. So when we did the Evolvable Lunar Architecture, we had multiple phases. Phase 1 was an expendable lunar lander. Phase 2, once we got propellant mining going and had the power, which is we needed at least 1 megawatt of power, and we were producing propellant on the moon. And I agree, the first propellant depot likely is going to be the depot on the moon. we then could have a reusable lunar lander. So just making that one change dramatically lowered the cost of having humans and cargo to go to from the moon. It had a 2/3 reduction in the total launch cost. You use the same launch vehicles, the same in-space transportation systems for humans, and you lowered the cost of sending a human to and from the moon by 2/3 because the most expensive thing in that end-to-end transportation system was sending a lunar lander all the way to the moon, using it once and throwing it away. That was a huge waste of money. And once you can make that reusable, and we assumed a reusability of 10 flights, you had a 2/3 reduction in the cost of human to and from the moon. So this is coming. I think it's inevitable. It was always in the baseline, even the SLS architecture, for those of you who like SLS, was built around a mission to Mars. It was DRA 5.0, needed 12 to 15 refueling missions in low Earth orbit to send humans to Mars. It's always been part of the architecture. The question is again, who, when, and how? To me, it's like, who is the customer? I believe there's other potential customers, but the most obvious customer is NASA with its commercial return to the moon that's in the budget, becomes the anchor tenant customer for a commercially provided propellant economy in space. And I use that very intentionally, a propellant economy in space. Once you start building out a propellant architecture, it creates the demand. You actually, you become the propellant station in orbit, and if somebody can supply you propellant lower cost, they have an instant customer. And so this is the way to resolve the argument between those who say they want to do propellant from asteroids or propellant from the Earth versus the moon. Like, go at it, guys and gals, right? Just go at it. And if you can deliver propellant to the depot, who's the customer, at lower cost than your competitor, you got an instant business. Because Herman Oberth was right. We're going to, the future of sending cargo and payloads and people throughout the solar system is going to be built, the last stop before leaving Earth, or the Earth Moon system, is going to be at a propellant depot and probably in lunar orbit. You can argue between L1 or L2 or rectilinear orbits, but they're all effectively the same from a delta V perspective. This is the future, and the only question is how we get there. Look forward to the further discussion.
Thank you, Charles. So you mentioned creating demand with a supply of propellant. The GAO recently came out with a report that talked about the chicken egg problem when it comes to satellites in space servicing, where there's not enough demand because there's not supply. So how do we overcome the chicken egg problem when it comes to in space servicing, specifically for refueling? And I'll leave that open to any of the panelists, that question. You mentioned NASA.
Well, my solution is NASA is the anchor tenant customer to kick this off. It's why I led the Evolvable Lunar Architecture study, pointing out, which was obvious, that NASA is known for years that they are the customer for this, for sending humans to Mars. If you look at Elon's architecture, he doesn't want to depend on anybody, but he creates his own propellant depot in low Earth orbit to fuel missions to Mars, right? But it's still a propellant depot economy that he controls all the infrastructure, right? So whether he's going to sell tickets to Mars to private commercial customers or NASA's going to be the customer, which is really kind of obvious that NASA is the customer. I think that's the answer. Now, maybe Dallas has got a different answer, or somebody else, but that's where I've been going. And that is the core of this is me speaking, not the White House speaking. That's the core of what the strategy for the COTS-like partnerships to go back to the moon and commercial transportation to and from the moon, which is in the HLS contracts that both Blue Origin and SpaceX have. If you look at what they're both proposing, they both do in-space propellant transfer. And it's an obvious layup to refuel those landers on the moon if you can. And the easiest is the oxygen. So that's, Ross is absolutely right. And it changes the economics. So to me, that's where we're going next.
So I would comment on the LEO satellite refueling or Earth's orbit satellite refueling. The most customers easily accessible are in GEO. The LEO constellations are in all kinds of different orbit planes, different orbit altitudes, and it's expensive to get to them from a single depot. But GEO, which Orbit Fab is pursuing, is where the most satellites are that could be refueled. NASA has developed systems to enable refueling of legacy satellites, but until a depot is there or until new satellites are built to be refueled, that customer base won't materialize.
Well, I think the customer base is there, Dallas. I agree with you. It's like you have to get them to be good customers of
Right.
refueling. So,
and the reason I focused on GEO and the lunar missions is because satellites have a small quantity of propellant on board, a few hundred kilograms, and transfer vehicles need hundreds or tens of tons to hundreds of tons to go back and forth. So there's a bigger market there. And it was also instigated by Mike Griffin's comment that if there were a propellant depot there, we would use it during the constellation phase.
well, something Mike Griffin and I agree on, right? So
Exactly. But it would have to be commercially said.
I'll chime in and say that, in our analysis, propellant depot and LEO, I mean, there's drag still in LEO, which is a real bad thing if you're trying to keep something sustained in orbit that's got a lot of mass. So being out in GEO, I mean, honestly, just being above where ISS is helps a whole lot as far as drag and how much you need for station keeping. So GEO and beyond is certainly con-op wise a much better place.
Right, but the benefit of the LEO depot, independent of where it is one can decouple the launch issues, the launch delays from the departure by always having more propellant on orbit than one needs for the upcoming mission. And so that takes that false claim, I would say, in the NASA study about the architecture for Constellation, that it created too much of a failure issue to have a depot in the loop. They didn't consider decoupling the launch missions from the departure mission.
well, the issue is, Dallas, they always knew they needed a depot. They were just lying about that. If you look at the Constellation architecture, DRA 5.0, you needed 12 to 15 SLS missions to fill up the spaceship with fuel, propellant, 90% of the mass to orbit to go to Mars under the SLS DRA 5.0 architecture was propellant.
Yep.
They needed a fuel depot or they had no mission to Mars. It's
That's
like,
correct. Yeah.
In today's commercial environment, there's a strong economic argument for doing refilling. And what it's driven on is the cost delta between a dedicated mission to get your bird, say, to GEO, and picking up secondary payload that's otherwise going to go unused, right? So economically, what it means is you can get your propellant refills up asynchronously much cheaper than you can get your primary missions up. And this provides you that reason to bring in and refill birds rather than just sort of shipping all your prop with you at the same time, right? So that's something that can be used to get this going and get the refilling infrastructure in LEO and towards GEO up. I see a day in the future where that economic argument doesn't exist anymore, right? So if you start transitioning from dedicated missions to dedicated locations, and instead you're just using like Starship or something as like a big heavy truck to get to LEO and you do in-space maneuvering from there, then your rate for cargo, it all flattens. It all comes to the same, right? You don't have that cost differential advantage. And at that point, you're stuck with the physics problem, right? And the physics problem is still the physics problem, which is you're pushing your bird and you're pushing your prop all through the Earth launch bottleneck. I'd be really excited to see a in-space propellant refueling setup get going before that economic structure changes, because then we'd have infrastructure ready to plug into with propellant exported from the moon, which actually takes away that physics problem.
Yeah, to glomp on to, I mean, we're all space resources, lunar champions, but
Yep.
there's the Pearl Harbor scenario where what if you can't launch things from Earth? There's aside from all the challenges of launching from Earth and the fact that it's, I think, what is it, 1/10 or 1/6 of the propellant is needed to launch from the surface of the moon. There's also no atmosphere on the moon, so companies like Auriga and Spin Launch, they could just chuck line replaceable units like we've been talking about, or tanks for that matter, without using any propellant, and get this into a lunar orbit where then it can be moved wherever, in the whole, what we're calling LEO, the whole cislunar ecosystem becomes realized.
Right.
Yep. And the moon makes the Golden Dome look like a Maginot Line from the back.
Mm-hmm.
So, Joe, you mentioned Pearl Harbor, and there's obviously a national security component to all of this. The Space Force has signaled their interest in dynamic space operations, which you would think would require refueling capabilities, but high-ranking officials at the Space Force have questioned the utility of refueling satellites in space when we can just build cheap ones and send them up by the thousands. What do you guys respond to that?
This is a profound failure of our national strategic vision. There was early on a decision that the Space Force was going to be a brown water littoral force and not a blue water navy. And that means there's no concept of resupply from above. There's no concept of a back of the Maginot Line. There's nothing, right? And so it's optimized for fighting, maybe 2027's war, which maybe is what should be done, on a near-term strategy vision. But China is going for the moon, right? China's in the Icon Basin because that's the place you put artillery, right? China's going to turn the moon into the South China Sea if we let them.
Mm-hmm.
And the Space Force is going to have to transition to a blue water force. It's going to have to fundamentally reconfigure itself. It's going to have to be a naval domain, not an aerospace domain. And if we don't do that ahead of time, we are going to have a Pearl Harbor moment. And if you go back to what Billy Mitchell was saying in the 1920s, that clocked right forward to 1941. He was dead right. There's a few people saying that today, but they're not being listened to.
Yeah, I can't help but echo that sentiment. That I've heard the Space Force folks. I think Space Force is quite divided among refueling versus the pros and the cons. But from what I understand, though, I think some of it is maybe some misunderstanding where. One of the comments I heard was, well, we haven't had a spacecraft fail because it ran out of propellant. And, well, that's because they're not designed to go beyond their mission once they run out of propellant. That's
They all fail when they run out of propellant.
exactly.
Come on.
Right. Well, the reason they haven't failed because they ran out of propellant because they know how much propellant they have in it, and they refuse to do something that makes it fail. Right. So. The issue here, I think, in the short term is I supported a good friend of mine is Gordon Russler, and I don't think Gordon's on. Some of you know him. He was the DARPA program manager for robotic servicing of geosynchronous satellites that was, building arms to refuel satellites in geo. They got partners and interest from commercial satellites for refueling. They also were focused on the DoD refueling. It was a hard problem. Every cap was different, and and you had to have a different way of taking off different caps from different satellites, and they didn't even keep track of it. So it's a hard problem, and it can be done. But in the near term, the reason I don't think it's happened really is a more of a business issue is the proliferated LEO came along, which, solves some of that problem, takes some of the pain away from these big Battlestar Galacticas in GEO, right, that are huge targets as the leaders of the DoD and space talked about. And they went to proliferated LEO as a way of having more disaggregation, more resilience. And so that solved part of the problem. And I totally agree that the LEO satellites, refueling them doesn't make sense. You have many more. It's harder to take them out. You're less exposed. So it's taking some of the pressure away. But I do think, there's evidence now that China is doing refueling right now. I just saw something in the last week.
Right.
There's 2 docked satellites, and one of them they say is refueling. It looks like China's doing it. So China's going to have this, the DoD calls it maneuver without regret. The United States needs to have it too. It's just kind of crazy. We should do this. We have the technology. This is not a technical problem. It's not a regulatory problem. It's a product market fit and get a customer to buy a problem. It's a business problem, and getting the US government, in this case the DoD, to commit to be the anchor tenant and go make it happen. And, that's on the leadership really now of the Space Force to go make it happen. And I think it's obvious, and I'm surprised it hasn't happened yet.
And I think the easiest path to enable the customers is for every new government satellite procurement should have a requirement to be refuelable in space as part of the overarching requirements. And that they don't have to be refueled, but they should be able to be refueled. And that would provide a customer base for those who want to provide propellant to satellites.
That solves the problem. Shepherding propellant works great in a peacetime environment. Once you find yourself in maneuver war, you're hosed.
Yeah.
So having DoD as a customer would create huge demand for this. But to make it not so much about national security, Charles, you also mentioned that NASA would be, in your mind, a very good anchor tenant for this. But as we all know, NASA's budget could be facing pretty drastic cuts on the science side.
I just want to
while
make
we
it
still
clear that at the deep space human spaceflight part of NASA's budget, and there's news coming out of the Senate in the last 48 hours. It looks like they're putting money back in on the science.
Oh, yeah.
But there is agreement on funding for commercial lunar COTS-like partnerships, that is in the budget. So that is not facing budget cuts.
Okay,
There's a growth opportunity there.
That's what I was getting at. Will NASA, whether or not the cuts happen, if the cuts do happen, would that affect what we're trying to achieve with refueling with sources from the moon? And you say no?
I think whatever side you are on in the debate with NASA, they all use refueling. And so I think that probably the toughest part that was getting cut, STMD, the Space Technology Mission Director in NASA, was looking at cuts, and they are funding some of the propellant depot refueling work. And if the Senate wins, that doesn't get taken out. But clearly the deep space human spaceflight with lunar resource utilization is a clear focus, is on the roadmap as a strategic priority. So I think this is coming. Again, it's a matter of when and not if.
Well, and NASA is really the indirect customer on the moon. The Starship, the HLS, and the Blue Origin HLS, they are commercial services. So the real direct customer for propellant on the moon is SpaceX and Blue Origin. So those are the ones that we should be talking to about being a customer and providing sales to them.
Well, yes, if you were in the propellant depot business and wanted to put that propellant depot on the moon, like Russ suggested, I'd want to persuade Blue or SpaceX to be my customer. But might want to make NASA make SpaceX or Blue be my customer. And, you're going to want to have a spot on the moon near the base. If NASA's the leader or the managing partner of that base, even if it's all commercially provided, they're kind of like the get to say whether you get to have a spot there, whether you're trusted enough to be there, right?
Yeah.
But yeah, that's probably how it's going to work.
I know SpaceX has said, we need to make sure we have customers too for these things. So I'm sure, that's at the end of the day, Blue Origin and SpaceX can't exist until forever without as the only customers.
And anything we can do to reduce their costs will help them build a customer base.
Yeah, let me emphasize that. So the Evolved Lunar Architecture study in 2015 looked at both the lunar mining for propellant as an export, but also discussed personal human spaceflight. Looked at that as a growth opportunity. That you'd have commercial crew and cargo to and from the moon, supporting a NASA base, initially a NASA base, but grow to be a permanent settlement. And the looked at what would be the cost of personal human spaceflight. Let's say you're Larry Page, and the rumor is Larry Page, one of the co-founders of Google, has said he'd like to take a trip to the moon. What would it cost? What's the marginal cost? So that using the assumption of that study, it initially, when you used an expendable lunar lander with that wasn't refueled from the moon, the marginal cost of one seat was $600 million. But once you got to phase two, where you just refueled the lunar lander, and that lunar lander was amortized over 10 missions, and you only had to launch one lunar lander to the moon lunar vicinity from Earth every 10 missions, it lowered the cost of that Larry Page mission to the moon to $200 million, right? So it had a two-thirds reduction in the cost. So there's going to be takers at that price point, right? There are billionaires who say, I'm going to the moon, right? I'm going to go spend a week on the moon. And there's people who will spend 50-60 million dollars to go into low Earth orbit. There are takers. There will be,
Absolutely.
private passengers who pay to go to the moon.
I think you're right. I've not initially. I was not a proponent of human flight. I've been convinced since then, changed my ways. But I think that we need to have a thriving cislunar economy. It's going to take all of the things, and it's shocking to me whenever I fly with Ross as a pilot and stuff, and it's amazing to see how much wealth there is in this country when you see some of these houses and estates that there are probably hundreds or thousands of people that will pay the kind of money that would take to develop this base foundational cislunar economy. And if we think about commerce, I think commerce has a big role here to encourage, of course, what the role of Space Force is protect commerce things. If we look at terrestrial, the highway systems, everything else, that's what we really should be thinking about creating. And of course, we need that's the best thing about people like Larry Page going is think about a hotel. I tell my kids this, like, there's a hotel. Think about how many buildings are needed to support that hotel. How many trucks support that hotel? Just that one place. So you think about that, a human, place with Larry Pages at it. There's going to be a shitload of other things that have to support that. And there's highways and everything else. And if those things are just like our highway systems, hey, we can move a bunch of propellant for that, a bunch of food, could probably also move a bunch of other things. Our adversaries don't know what we're using it for. I mean, this is a really nice. We already have a roadmap for how this goes. We just need to actually do it in space. So,
And people are the key. People are the key. Moving people back and forth is the key to an economy in space. Cargo, one way, science, not so much, but people. You need people.
Nobody paid attention to Apollo after the first launch until like something happened on Apollo. Let's face it. That's the thing is like we need to get the rest of the world, not just a bunch of us in the room, thinking about that and excited about it. And that's what that does.
So will we see the cislunar propellant depots built up in space before space tourism to the moon becomes a real thing because it'll lower the cost so much? Or will they kind of develop in tandem? Or will it be space tourism first and then people realize, oh, there's a market for this, let's build this?
There will be depots in space, in Earth orbit and at the moon for Artemis missions to happen. SpaceX needs them. Blue Origin needs them for their 100-ton transporter that they talked about a couple of months ago. They need to refuel their systems. Their landers need to be reusable according to the long-term contract goals of what NASA has given them funds for. And it reduces their need for propellant in LEO if there's propellant on the moon. So, but in order to get there needs to be depots. Starship, in my view, cannot go from LEO to the moon and back. It cannot even get to lunar orbit, or from the gateway down to the moon, without having more propellant than what is in the Starship when it gets to the moon. So there will be depots before we have Artemis 3 and 4.
Is that something that NASA is considering now, or are they just pretending that
That
That's
is
something the
in
providers
the
are doing. That's something the
Tyler, it's
providers are
in the
doing.
agreement.
Okay.
That NASA's agreement with the two HLS providers, Blue and SpaceX, for their commercial lunar landers. They don't land on the moon and take people off without with in-orbit refueling, right?
They don't. They can't.
That's the only way it technically works. It is impossible for those vehicles as designed to work unless they do refueling in low Earth orbit. That it is built in from day one, right, for both of them, right? And just the background here, and I've talked to Jim Bridenstine about this. He got briefed in 2015 on the Evolvable Lunar Architecture study, and he told me years ago that that study gave him the confidence to make to that HLS would be a commercial program, partnership program with these two companies. So ELA is the roadmap, right? Refueling is on the roadmap. All paths go through refueling and orbital propellant depots.
And lunar
So
propellant just
is there
makes it better.
time to develop those depots before the Artemis 3 mission? Or is that going to be something else that sets back the clock on when we actually do Artemis 3?
They have to be
Well,
there.
But
just so you
how
know, they're
far are
each
we
building,
from?
Tyler, they're each building their own depot, right? If you go to Blue,
Okay.
they have their own depot, and
Right.
SpaceX has their own depot. And you can go just Google, SpaceX Starship propellant transfer. After they land the Starship and prove and they can turn it around, very immediately they've talked publicly about doing orbital transfer demonstrations, orbital propellant transfer.
Yeah.
It's very near term.
Yeah, two
Okay.
starships in orbit make a perfect depot.
So I've heard similar things, Charles. However, I have not met anybody directly working on this yet, which I might not have crossed paths yet, but I have met a lot of people, and that makes me wonder what the time frame actually is before we have those capabilities.
Well, maybe they consider what they're working on as trade secrets, and they don't let the engineers they lock them in a room and say can't talk to anybody. Like, don't go talk to Joe Pawlowski. He'll steal your secrets.
Could be it. Yeah.
And I've been told by folks at both companies, I can't talk about that.
Yeah.
Oh.
So we've established that NASA and DoD will be a big component of making this all happen. But besides the national security aspect and just the science aspect of it, why is all of this important to the United States just in general? If I'm a guy who doesn't know anything about space, and why do I want my taxpayer dollars going towards establishing cislunar infrastructure? Why should I care?
I don't know that you should, just like you don't care about where oil dumps or fuel dumps are.
But why should I care about my taxpayer dollars being spent to establish these kinds of things?
You should care about your tax dollars being spent to get science and get knowledge and to stay ahead of everybody else and stay in the game, independent of how it's done.
I'm gonna let Russ and Joe take a stab at that, and then I'll give you my answer as part of that, as a volunteer for the Trump-Vance transition team.
I can't hear your take, Charles. Mine is this. 1492, China had a superior exploration fleet to the United States. They had ships that made Columbus's fleet look like fishing boats. They had an internal political decision. They decided not to continue with it. They burned their ships and turned inward. And then in the 1800s, we came in from the east, from their east. We colonized the Americas. We came across the Pacific. We showed up on their shore with compounded superior technology because America was the new continent that was going to be the linchpin of geopolitics. The moon is the eighth continent of the Earth. It's part of Earth. It's bound to ourselves, bound to us gravitationally. It is the high ground. Whoever controls the moon controls cislunar space, controls everything we do on the surface. And that's why we can't seed it.
I just add on to what Ross said. I think about, Pearl Harbor. Japanese thought they'd destroy our whole Pacific fleet and we'd be screwed. Except we came roaring back. The sleeping giant awoke, and we had all these resources because we had the high ground. And I think that's the same thing with the moon. There's unlimited possibilities for what we can create over there, and logistics of getting it into this cislunar environment.
So I agree with Ross and Joe, but let me add a few points. One, that comparison between the Chinese fleets and what happened later. Really, 1492, Columbus took the Nina, the Pinta and the Santa Maria to discover the New World. So it came earlier, but within a couple hundred, 100 or 200 years after China canceled their fleets. I'll just point out this is all the fleets out of Portugal and the Dutch East Indies and the Dutch and the British, they were based on economic growth. They were economically supported. The Chinese were not. It was just a pure government program without any economic return expected, and it was unaffordable. That we should learn that lesson. If you don't build something based on economic growth and free market enterprise, it collapses as unaffordable if it's all it is the government paying you all the time. So that lesson was learned hundreds of years ago, and we're learning it again. The second thing is I absolutely agree that the reason to go to the moon, President Trump said it in June of 2018, we must dominate space, right? We must beat Russia and China in space. And if we don't, it's the end of freedom for human society for the next 1,000 years, right? Whoever dominates space dominates the Earth. So how do you dominate space? You dominate the emerging commercial space industries. That is their strategy. They are dominating rare earth metals. They're dominating drones. They're dominating electronics. They're dominating maritime vessels. They're using this as strategic leverage for their country. And they are now pursuing a leapfrog strategy for RLVs and space resources on the moon and all these other industries and capabilities we've been talking about. And if we let them leapfrog over us, they will dominate these emerging commercial space industries with deep subsidies. They will use it to become the dominant military space power, and they will then dominate the Earth. It's like 1, 2, 3. And so how do you win that? We must, use public-private partnerships. It's the American entrepreneur who is our superpower, right? That the American free enterprise spirit, our entrepreneurial spirit, our innovation go faster. That's the only thing that can go faster than China, and do it in partnership with the U.S. government. And that's how we make sure we extend the blessings of liberty to all humanity for the next 1,000 years.
Great.
Yep.
Thanks, guys. Great
Here,
responses.
here.
So let's turn to the audience questions. We've only got about 15 minutes left. First question is here from Jeff, and this is for all of the panelists. How worried are you about space debris for propellant depots in all orbits?
Systems will have to be shielded and shielded to the extent that you want your system to last. So shielding exists on space station for that very reason. China is adding it to their space stations for that very reason. And we'll have to do the same for propellant depots to keep them from becoming debris.
Yeah, I think it's there's early on we were doing a lot of work on how do you capture space debris and take care of it. It makes sense to try to go after school bus size space debris with technology we have today. We're not going to be able to do a lot about the smaller debris other than shield things. And as we move forward, we really like the idea of designing satellites and everything in a modular fashion where they don't die, they just keep getting upgraded. And then, satellites that maybe are towards end of life, perhaps you bring them to a depot and then they're, salvaged or something. So you don't have that potential for debris on orbit. So I think it's a lot of, we're only going to get more things on orbit. So it's a lot about how we think about it. Nobody wants to have a harbor with a ship sunk in the entrance because that screws everyone over. So it behooves all of us to not let that happen.
I'll just add to that the one key missing thing on space debris, I think it's legitimate to like ask everybody to be a good citizen, not throw junk in the street. But once junk is in the street, every city solves this problem around the world for the last 100 years, right? Is like somebody pays the street cleaner. Right? Somebody pays in the city, pays someone to come along in the street and clean up the junk. Now, if you go across the world in the nearly 200 countries, they solve this in different ways. Sometimes it's just the government does it. Sometimes it's private fees for a private street cleaner. Sometimes there's culture where everybody's expected to do it, or you get yelled at by your neighbors and then you do it because it's just the norm. But they solve it in a different way. And we are not, we as long no, we don't want to pay the street cleaner. If there was a customer to pay for cleaning up debris, like the largest stuff in low Earth orbit, like the Zenit second stages that are huge, like buses, someone would go build a business to do that. But we're not serious until we're willing to pay the street cleaner.
Here's another question from the audience. I think this is directed more for you, Ross, but I'll leave it open for anybody. When you say chucking propellant tanks from the moon, do you envision a railgun concept, or would physics still require a launch vehicle?
Well, so I want to focus on developing ISRU propellant first because you need that for that soft takeoff ability to get humans back and get your reusable ships back, right? So let's not add complexity to the technology stack. But yeah, the moon favors kinetic launch. Railguns are one thing. Spin launch is great. A couple kilometers a second gets you off the moon. You do still need to circularize your orbit. You do still need to get where you're going once you've got that initial kick. So it's probably a hybrid system where you have small, inexpensive thrusters that take advantage of a mechanical kick.
Yeah, we've done some high level proposals on this sort of thing, and spin launch, the launcher that they have in New Mexico is potentially large enough to launch something, get enough delta V on the moon, which is pretty cool. So there's an example of that. There's another company, Ariga, who's doing some really cool stuff with railgun, or they're actually coil guns. And so, something like that, you might be able to get, you probably still need a kick for circularization, but you get the bulk of that delta V without propellant, which is really neat. And we've had some wild concepts where you have something else that's orbiting that captures it and circularizes. So there's a lot of interesting concepts your mind can go wild with. People need to start thinking about that now.
Another question from Jeff. He's got lots of them. They're good questions, so I'm going to ask this one too. If Musk can get Starship to cost less than $100 per pound to orbit, wouldn't it be cheaper to just get propellant from the Earth, despite the difference in delta V? Or does it still make sense to get propellant from the moon, even with Starship?
Phil Metzger had a great study that he presented at Space Resources Roundtable a couple of years ago. And he showed that independent of launch costs from Earth, it eventually always became cheaper to get propellant from the moon because it costs you less to get the material you need to do that to the moon. And therefore, the cost of the propellant on the moon comes down. So at some point, it's always cheaper to get it from the moon, independent of launch cost.
Physics drives economics.
Yeah.
And terrestrially, we see examples of this everywhere. We often don't ship water across the ocean.
Right. Well, let me just say that I agree in general with that. On the margin, though, if you have one technical break, so there's three different major sources of propellant. One is the moon, one is asteroids, one is Earth. On the margin, if some technology of one of them changes, it might shift the advantage slightly, the competitive advantage of one source from one to another, but it depends where. So if you're talking about bringing propellant to LEO, it's harder to justify bringing the propellant off the moon and all the way down to LEO when you can just launch it from LEO. It might shift the advantage to Leo, say, if you're in rather than the moon, but and then there's some people who argue I'll capture an asteroid and put it in L5 and mine it there and mass produce it. Maybe. And so, but if you create a propellant economy in space with a customer which is the owner operator of the propellant depot, they really don't care.
Right.
They'll sign a contract with you as the asteroid provider or the low Earth or the Earth to orbit propellant provider, and you commit to a price, and they don't care if you make money or not. If you're delivering at that price, right? It's all on you. If you want to take that risk and you can get investors to give it to you, you get a shot. So that it changes the calculus there.
Right. Right.
Broadening the scope of the answer a bit, there are non-economic limits to the amount of mass you can chuck off of Earth, right? There's only so much you can combust in the upper atmosphere, and when you're re-entering hypersonic vehicles, you're cooking the atmosphere into NOx, right? So you're putting those gases up there. So if you do say 1 million tons a year to low Earth orbit, you're already looking at an impact that's about maybe 10% of what we're doing with commercial aviation worldwide right now. So it makes sense to optimize for getting precious things that you can only make on Earth, people, things like that. Push those through the Earth launch bottleneck, right? And make that strategic investment in having all your dumb mass and everything you can possibly get from space sourced up there. That's how you get to a Type 2 civilization.
Well, now you're talking like Jeff Bezos, who wants to zone the Earth. What did he say? He wanted to zone it,
Yeah,
light industrial. So,
Industrial, residential, national parks.
right,
Yeah.
right. And then the hardcore industrial goes all off planet. So, depends how long term you're thinking.
So,
It depends.
I'm ambitious.
It's a great vision. It's a great vision.
so who would be allowed to live on Earth then in the future? In that future, we have to chase everybody off and then just let certain people come back, right?
I think the idea would be Earth is for living, space is for industry, or something to that nature. But yeah.
Sounds
Well,
good to
he's
me.
talked about 1 trillion people in the solar system, so I think he's thinking people throughout the solar system in this
I
world.
guess I'm thinking like space is going to be awesome. I can't wait to go to the moon and other places. But the Earth is pretty awesome. And it's going to be thousands of years before we have places like we do on the Earth to enjoy on Mars and other places, probably.
In every society, the economics of abundance favors environmental stewardship, right? Environmental degradation comes from poverty. So I'm not worried at all about conflict.
Yeah.
So one more question here for the whole panel, for all the panelists. So Beyond Earth Institute, we are a think tank. We focus on policy. So real quick before we turn things back to Steve, what is one policy you would recommend the United States government start today to make cislunar refueling a reality? Joe, you can go first since you were the first panelist to speak.
Oh, I was hoping to hear what other people had to say.
All right, well, you can go last then. We'll do it backwards. Charles, you want to kick things off?
Can you repeat that question, Tyler?
So what's one policy you would recommend that the United States carry out today to make cislunar infrastructure for refueling a reality as soon as possible?
I would say Congress, agrees to and funds the president's proposal for a COTS-like partnership on the moon. We need to have commercial crew and cargo to the moon. And we already have 2 lunar landers, commercial lunar landers. We have commercial Earth to orbit launch. You need to do it end to end. We did commercial crew and cargo to and from the space station. You need to do commercial crew and cargo to the moon. It's proven, it works, it's much cheaper. And I think the answer is there. We go do it, and that will create a demand for cislunar propellant, like Dallas has already stated. It's happening. It's built into the architecture already.
So that reminds me of some concepts. I think just adding on to this, like one tangible way to potentially do this is, if our government Space Force purchases launch mass to Leo, launch mass to Geo, launch mass to the moon, and has a regressive time. Okay, this year we're going to buy thousands of tons or whatever at this rate, $1 million a ton to the moon. Next year, it's going to be 90% of that. And by whatever in the future, we expect it to be this price. It's bid every year. Those that can get it, that have proven those flights, are going to, bid on getting that up mass, so we can diversify our suppliers. But I think for folks like Ross and I and Dallas, having that guaranteed launch or mass that we know we can rely on at a certain price, certainly our investors and everything want to know that. But that to me, that's the big, variable cost, is what's it going to cost me to get some to the moon or to geo. And if I know and also availability, like most people that aren't in the deep into it know that, those of us that launch things, like there's not a lot of availability, and that hurts the time frame for us to get, to prove out some of our technologies. It could be 6 months to a year before we can get on, or longer. So knowing that is, that the price is set, and also knowing that it's going to be there for sure, would really help a lot.
Ross and Dallas?
Go ahead, Ross.
I mean, echoing, Charles and Joe, absolutely, 100%. Taking it, up just level of abstraction, an algorithm that lets you set your policy. Pace China. Their central planning system is really good at setting goals and really good at running a time frame, right? Our free market system is really good at building momentum and executing, right? So, right now they're setting the terms of the game.
So I would say explicitly what Charles talked about with the commercial cargo and crew to the moon. I would say and agree with the Trump proposal to eliminate SLS and Orion from the architecture. Having that is absurd given what others are doing. Plus, echoing what Steve Wolf said at the beginning, committing to a N number of people permanents on the moon for science, research, whatever, for whomever, and buying services wherever possible, and only conducting paying for science missions by NASA at the end of the chain, not that whole transportation architecture, but at the destination, and focusing everything on getting there from a commercial basis and operating the base commercially like we do at Antarctica. Those are the keys to moving this along faster.
All right, guys.
One difference with Antarctica,
Sorry,
though, Dallas, is they got wrong. They don't allow private passenger travel to Antarctica. You can step on there, but you can't stay.
Right.
I think we need to, explicitly have commercial private passenger travel to and from the moon. That needs to be part of the vision.
And Antarctica, there are tourists that go to Antarctica, but the bases are operated by a commercial entity.
Right.
All right, guys, we're almost out of time here, so I'm going to turn things back to Steve, but I want to thank you very much for participating. I really enjoyed the conversation, and I learned a lot. I hope the audience learned a lot as well.
Hey,
Steve, back to you.
Yeah, hang on a second, guys. Really, I wanted to just compliment you all. This really was a bit of a master class on propellant depots and many other aspects of the cislunar infrastructure domain, not only in terms of the ins and outs of the technology, but also the history of this, both near term and deep history, and the rationale for why we need to be moving aggressively. And I have to say, Charles, I know you're great on the platform. Your particular speech about U.S. leadership in light of what China's doing just made me feel like I've got to find out where I can donate to your campaign, because I'm going to vote for you next time around, without a doubt. So, Ross and Joe, thank you so much for being the newbies in this space. Really looking forward to seeing great things from you guys and from your companies. And Dallas, thank you so much for ending this on a note where we kind of started with this idea of, can we set a goal, for a permanent base? I mean, I think that we're thinking of that as sort of like a focusing way, or an organizing principle for a lot of this activity, and helping us move in that direction. So with that, thank you guys. I'm going to move over. I just want to share with you all I want to share with you, and this is for the audience. So our next webinar is going to be on July 30th, Eat, Love, Play in Space, Exploring the Fascinating Realities of Human Life Beyond Earth, being moderated by our own Steph Recchi, who's a member of the board of Beyond Earth. And so this is going to be a very interesting, exciting program. We hope to see you there. Welcome to see you there. So with that, thank you guys for coming. We're always interested in your interest and comments and questions. And with that, I will let you go and have a wonderful day. We'll talk to you next time. Bye now.
Thank you.
Thanks, Steve.
Thanks, everybody. Thanks, Tyler, Steve.
Thank
Bye
you.
now.
Good day.
Thanks, everyone.